So I've got another pair of lines here. I thought it might be fun to see where they intersect. So we're going to do the same set as before, compare x components, compare y components, and see what happens. So x, we get negative 4 take 3 lambda, and equals negative 2 plus mu, which we can rearrange to get 3 lambda plus mu is negative 2. And then so that's the x components. For the y components, we could do 3 plus lambda from R1. From R2 we get negative 3 plus mu, which a bit of rearranging gets us lambda take mu equals negative 6. And that looks simple enough to actually eliminate ourselves, so why not add these and see what we get. We get 4 lambda equals negative 8, so lambda is negative 2. Then in this equation we get negative 2 take mu equals negative 6, which I think means mu must be negative 4. No, it must be 4. Mu must be 4. And then we'll just check what point that gives us. So from R1 we get that P is equal to some components. In the x direction it's going to be negative 4 plus 6. It's going to be 3 take 2 and 1 take 4, which is 2, 1, negative 3. And from the second equation we're going to get that P is equal to negative 2 plus 4, negative 3 plus 4, and 5 plus 12, which gets us 2, 1, 17. This is negative 3, which is why that was negative in the first place all the way over here. I'm really sorry about that, folks. This was negative 3 all the way through. So we get 5 take 12, which is negative 7. Now, these are not the same. Now, I assure you that's not because of my sign error, as I've done this before on paper and just miscopied out this negative. You can check yourself that when you follow this through, you do get these exact values. You'll actually spot that those are the same, and that's because they're the values that we actually use to find mu and lambda. So if they weren't the same, there'd definitely be a mistake going on. But the z is different. Now if you interpret z as a direction, that means here that this negative 7 is below this negative 3. So this line passes under, in some sense, this line. And that's a new thing. In 2D, whenever I draw two lines, unless they're parallel, they will cross somewhere. But in 3D, this line can be above that one and go past it. So it's perfectly possible for two lines in 3D not to touch and not be parallel. They can. This name, what we call these, is skew. And that's a new arrangement which we haven't had before. Now we're working in 3D, you can get these things that are skew lines. Lines that do not touch each other, yet are not parallel. And they're still lines. And that's simply because there's an extra dimension that they can separate through and pass each other. And in fact, you know that already because you know planes don't crash. There's enough space in the sky for them to get past each other. It's not a problem. So, look out for those problems. And just in 2D, you also get lines that, while they look different, are the same line. That's a trap you can fall into as well. So do pay attention to that, and I hope you can get that yourself.